right, guys, so our second methodological session today is introducing the new BayesACT software. And there's a couple of different versions of this. So Jesse has, as he mentioned, created an all-new code that runs in C. It's much quicker than the code before. It implements these new semantic transform models that move between connotative and denotative spaces. So all the things that you've heard about the BayesACT models in the earlier presentations today apply to that interface that he's built, as well as the interface that we've been working on here at Dartmouth with Jesse's help, which is a point-and-click interface. So similar to the kind of Surveyor 3 stuff that we were talking about, I felt like it was really important to have this software as a means for people who are not as comfortable using command line prompts to really be able to take advantage of the BayesACT models and some of the build some interesting kind of experiments or run simulations that they can test qualitative findings against. You know, the traditional ways that we've used Interact as a way to design studies that we can then test. And it's more important than ever because we've got all of these moving parts now, right? We really are starting from scratch in a lot of ways and understanding things like the alpha issue, which we've been talking about a little bit today, and understanding what uncertainty does, what noise does, whether or not we might want to manipulate beta, all these different types of things. So if you are more inclined to code, if you feel comfortable playing around in the C, Jesse has an interface that has a fairly straightforward command line system, and you get output that looks just like it used to. It's kind of a big block of text, and you can look over it. That software is more flexible, especially if you know how to work within the code. You can make modifications to the model that are not possible in the current version of the software we're going to show you today. But there's a few kind of key advantages of this, what we call GUI, graphic user interface version of the software that I wanted to point out. You'll find a little short kind of instructional guide in the packet that I gave out yesterday. It's on the left in the back that walks through what those benefits are and some kind of basic instructions for how to use the current version of the simulator. But basically, one major advantage is just that it's a simple point-and-click kind of interface. Once you get the hang of it, it's pretty simple to navigate. It gives you 3D data visualization. You can kind of grab the plot and manipulate it around and see things from different angles, which, as you'll find out very shortly, becomes super important when you're dealing with the output of BayesACT simulations. It actually takes quite a bit to digest what you've received, so that it's a little bit different from working with Interact output in that sense. It also has a really flexible design that capitalizes on a lot of the benefits of the new models that Jesse's put together. So using the software, you can specify multiple identities and their relative probabilities for each agent you're simulating. So you can say this person is 0.5 professor and 0.3 mother and 0.1 something else, right? You can specify what that distribution looks like. You can also model one agent's interpretations of events or both agents simultaneously, as Jesse mentioned. So it adds this wrinkle of being able to send behavior and emotion signals simultaneously. And you can modify several of the model parameters, not all of them, but the alphas, the betas, and the number of samples that you're using in your simulation, right? So it has a lot of the key elements that you might want to manipulate for study designs or tests of ideas that you have. One of the really nice things that I really wanted to push for with this software is that it would not require you to install any additional software, to know Python, to do anything else, that it would run on any machine, which it will eventually run on Windows. It's not running on Windows at the moment. But the idea is that if you download the right version for your computer, you open it and you run it, and that's the end of it. Right? It would be just like Interact in that sense. It should run on virtually any machine. You are? Okay, so folks can try. I couldn't get it to run on the Windows machine that we tried 32 and 64. Yeah, so I mean, you're welcome to give it a shot if you want to see if it'll run on your machine. I've got it running on Mac fine. Yeah, so the software comes up, but the data, it doesn't populate the data. Yeah, that's what was broken about it. So you can still, if you want to open the interface and look at it, it just doesn't, the data is not populating from the demos that we're running today. Yeah. Yeah, and I should mention, like, one of the things we're really hoping to accomplish today is to get your feedback on this, right? I really want this to be something that if you have an undergrad or a graduate student, or you are a graduate student and you have a passing, casual interest in BayesACT and you want to know more about it, that this is approachable, right? You don't have to invest a lot of time in learning how to code or installing. Like, even for me, when we were working on the ASR paper, just to get the actual Python version of the software running on my computer took an irrational amount of time because there's all these different packages you had to have and stuff. So I wanted it to be something that had no contingencies and that was fairly straightforward and interpretable for people. So hopefully this will be that once it gets into its final state. So we'd really, really appreciate your kind of user feedback today, tomorrow, or anytime going into the future, because this is obviously a work in progress. This is hot off the press. We literally just finished this like 5 minutes before, like 5 minutes before this session. So Doug's been working super hard to get the latest version implemented. As I mentioned, this isn't in its final state. There's some features that this will have that are not represented in the current version. So I'll just go ahead and show you what the interface looks like. So once you've downloaded and unzipped the file, you'll just run this lovely program here, BayesACT version 0.2, because we can't even call it 1 yet. It's incomplete. You'll pick a screen resolution, hit play, and you'll find yourself in an interface that looks sort of like Interact. There's 3 main menus here, right? Import, export dictionaries, explore data, and simulate. These first 2 panes are not working yet. Okay, we wanted to build the core, the simulation function, and work backwards to the peripherals so that we made sure that they played nicely with each other. But I think it's fairly straightforward what these will do. The import-export dictionaries function is, to bring your own data into the software. We're currently using, what, Georgia? Georgia data in?
Depends, you specify that in the simulation file.
Okay, I mean for the demos today.
I can't remember.
Okay, not important.
We can look at it.
And then the Explore Data tab, so one of the things you'll see when we look at the simulations is that we have a nice interface that allows for 2-dimensional or 3-dimensional viewing of the simulation output, and it makes it loads easier to kind of figure out what's going on and overlay things and look at different things side by side. The same sort of interface is going to ultimately be applied to exploring cultural dictionaries and being able to plot 2 dictionaries on top of each other or something like that. So just you can kind of envision what that'll look like by seeing what's happening in the Simulate tab, but both of these are just empty for now. Today we're going to focus on the Simulate tab, which you move through these kind of logically left to right, right? The very first screen you're going to find yourself on when you go here is setting the BayesACT model parameters, right? So they are set for you by default to Jesse's recommendations, but you can manipulate any of these that you want, right? And Jesse talked a little bit today about what beta means, what alpha means, what number of samples does, but I also gave a little bit of an explanation in the packet. So number of samples is a little bit complicated because it's contingent with all of these other aspects of the model. But the main thing that you need to know for now is if you don't have a great processor or you set a large number of samples, this is going to be really slow. So you might not want to go crazy if you're just trying to play around with it on number of samples. Alpha, as you know, is the value that governs the strength of the affect control principle as it pertains to agent, behavior, or client, which is basically how much do I believe that people are going to act according to cultural prescriptions. And beta are the values that govern how much variance we expect in the identities associated with agent and client. In other words, how much do I believe that connotative meanings for the identities involved in the interaction are going to stay the same over time, right? So I would be really interested actually in people playing around with these and seeing what it does to, we don't know. Like honestly, this is so new, we really need to understand and test against real world situations to know optimally how we should be setting these parameters for different social settings and such. So once you set the parameters, the next thing is to define the interactants. Ultimately, this is going to be a screen somewhat like Interact, where you can make specifications, except you'll be able to set different probabilities, right? The probability of this identity, that identity, another identity. So there'll be like a multi-select function. But for now, there's this initialize simulation from file button. And what this does in the demo version is it pulls up some different demo files that have different pre-programmed agents in them. And if you want to do something more complex, you can go edit those files and bring different agents in. It's pretty intuitive actually to figure out what you need to change the agents that are in play. So you can play around with it in that kind of roundabout way until we get the define interactants interface set up. I'm just going to start with that one because I think that's the one you're using first, right?
Yeah.
Okay. So once you pick one of these demo files, and ultimately, like in the final version, once you set your interactants, this is what you'll see, right? These are the default. You'll probably notice. Okay. Go initialize simulation from file. That's what I did. And pick TextSim Interact.
All right, I go back to that one?
Yeah.
And then double click on it?
Double click or click it once and hit open. Either one will work.
So that, it's not doing anything.
It takes a second.
Which one are
Go
you
to the
using?
Simulate
Is it
tab when
TestSim?
you're done with that.
Which one are you using? Is it TestSim?
TestSim Interact is the first demo file that Jesse's going to use. So you've got to go to Simulate Events now.
If you click on it, it goes away. So I assume it's.
Just go to the Simulate tab. Okay, guys, so just to clarify, like I said before, you move left to right. Once you're done on each screen, you move to the next screen yourself. It doesn't automatically take you. So you'll set the parameters. Then once you've set the parameters, you'll click Define Interactants. In our case, you'll pick a demo file. Ultimately, you'll actually define the interactants. And when you're done there, in real life, it will show stuff, but right now it doesn't because it's a demo file. And then you click Simulate Events, okay? And then you should automatically see what I'm seeing right here if you picked TextSim Interact. There's a couple of really cool things about this interface. So one is that you can snap your view to any orientation you might want that's 2D. So what we're looking at right now, E is the x-axis, P is the y-axis, and A is the z-axis. It's going away and towards us. No sound again? I clicked it. Try again. Hello, hello. Hello, hello. Okay. But you can snap to other orientations that are 2D and get different angles on the data, okay? So sometimes it's just too much information in BayesACT to process mentally at once, and snapping to a 2D is sometimes helpful in just like getting slightly different perspectives on the data. But the super cool thing is that you can grab anywhere on this plot and move it, and it becomes 3D. So you can manipulate this and look at it from any angle that you want to. And this jiggle function, you see they're dancing around. This is because a lot of times points wind up obstructing each other from your viewpoint. So the jiggle thing lets you see all the stuff that's there, but you can turn that off if you don't want it to do that. The other thing it does is there's a nice little dictionary checkbox here, so you can overlay dictionary data on what the connotative stuff that's coming out of BayesACT. And you can compare the actual, EPA values and what they mean back in the dictionary that you're drawing from for your study. And any of these points that you click on, it'll tell you what it is, right? Your EPA, what the associated label is. So I just picked rapist out of thin air. And these are a little grayed out just so they're not, again, not obstructing the actual data that came out of your simulation, okay? Doug has added the kind of nice feature that things that are negative show up red. So you know right away if something is a polar negative or a polar positive when you're looking at this or any of the data over here. So again, just simplifying the massive amount of information that you're sifting through when you do this stuff. Now, in terms of this right pane, in this case we've only specified one dyad, but you could have one of these files, or you could on that screen ultimately when it's there, you could specify lots of different dyads that have different qualities and people can interact with different people and all kinds of complicated stuff. But for our purposes, we're just setting a dyad. And because that's complicated enough. And when you look down here, you'll probably notice that you can compare the situation with two viewpoints side by side at the same time. What we've got here is there's basically four distributions in BayesACT for the identities. There's the current agent's perception of themselves, the agent's perception of the client's perception of themselves, and the client's perception of the agent, because everything's happening simultaneously, right? Or can. So but that's a lot of information, right? But one of the nice things here is that with this viewer and viewing tab, you can either say, I want to know what Hank thinks of himself versus what he thinks of Tom, and put that list of information side by side and visualize those things together. Or you can say, I want to know what Hank thinks of Hank and what Tom thinks of Hank, and visualize those things side by side. So these are just some tools that, and as I was brainstorming, I thought would be useful to social scientists for the types of things we typically do in constructing experiments and other types of research for testing simulation data. But I'd really appreciate your feedback about how well this is working and if something is missing. As you'll probably notice, there's 4 values here. The first value, the one that's in blue, is the probability, right? So we're looking at the probability of different emotions, and as you can see, awestruck comes up. Awestruck. But you can view emotions, you can view behaviors, you can view identities in the same way. There's only one identity each here because this is the initial specification that we gave to these people. Hank, I think Hank is a secretary. Yeah, Hank is a secretary, and he thinks Tom is his boss, right? Yeah.
Is there a way to view it from someone who's not in the interaction? I mean, I know everyone has to have their own sort of belief system, but in interaction you can view it from, you can think about viewing an actor, object, or the whole thing from a third party. So
you can do that with the models, but we don't have anything in the interface that, like the current dyads we've programmed for this demo, that's not one of the ones we programmed. But it's possible, but we need to think about how the interactance versus the viewer viewing thing would work for those types of situations. So that's a great point.
The third thing that social scientists want to use is
yes.
How is this viewed from an
outsider's point of view. Yeah, that's a great point. Are you making notes, Doug? Okay. Excellent. Okay, so anyway, this gives you a basic idea of how the interface works. The next situation has the same basic structure, except this is the planning aspect, right? The current situation tab is what happened just now, right? It's the output of whatever happened in the last round, or at the moment, it's just whatever you specified about the situation. The next tab is planning what you're going to do in the future. So this is where you actually start to set different outcomes here, and Doug added the nice feature of actually having the display at the bottom of the screen what you've specified, because there's so many moving parts here. It'll actually tell you how Hank thinks Hank is feeling and how Hank thinks Tom is feeling and what their actions are in a sentence. So it's just, you can feel really confident that you've done it right, because we found that one of the trickiest things was knowing who was seeing what from whose point of view. It's just, there's a lot of viewpoints at play at once. So this table is really helpful. And once you've made your settings, you can hit run, and you'll automatically be dumped back on the current screen with the results of that iteration. Okay, so it's, hopefully the structure is fairly familiar in terms of Interact. If people are familiar with Interact simulations, yeah. So this is where you choose actions and emotions for people to convey. All right, and I think as Jesse plays around with this, you'll get a better sense of how those things work. So one of the things that you can do on the, you don't think it works?
Well, the number of samples should go up to 10,000, but it doesn't.
Okay.
We'll try it.
Okay.
Okay.
So there's a mimic interact function on the parameters screen that we're not totally sure is doing what it's supposed to be doing. We'll find out. Debug in progress. But typically what this would do is adjust the parameters automatically so that if you wanted to run a simulation here, that would pretty much be as close as it can to the interact simulations using a Bayesian model. Am I saying this correctly?
Yeah.
Then you can just check that button and you don't even have to know how to set the parameters. It'll just do it for you. It didn't look like anything moved on the screen, but it might still be telling it in the software to use those parameters. So we're about to find out if it did.
Unless you restart, it's not complete.
Oh, I see.
Not to change anything on a running simulation.
Okay, that's right. That's why. You do have to do these things in order. So just close it and reopen it. We don't have that backstepping function built in here yet.
Can I show the text file before you do that? Show what it looks like?
Yeah, sure.
Or is that, you just want
It's in
to
this
see
folder,
the interface?
isn't it? This one?
Yeah. Does that make sense to do
Yeah.
that?
You might have to make it bigger. Control.
Oh, that's too small. No one's gonna be able to see that.
I'm making it big. Is that legible?
Okay, so this is those text files look like this, and the idea is that you specify just a very, very simple language. You specify different agents, and each agent is specified by a set of dictionaries, and the dictionaries have a type, which is, they can be mean valued dictionaries, so the original ACT dictionaries are just the mean values, or the Indiana, there's some of them that are in, yeah. And then I also, in this package with this is the new data where I've computed covariances. So some of these files will have the full covariance matrix included. So this one here that we can play with later will have that. So then it'll be, how did you do that?
Control plus. I mean command plus.
So then these ones here have a covariance tag, and that means that they are including the full covariance matrix, right? So then you define different agents. So this is a different file. So you have Sally and Tom and Dave, and you specify their dynamics files and their emotions files. So they can all be different, right? They can all be using different dictionaries if you'd like. And then you specify a set of interactions where you describe how each agent sees each other's agent. So for instance, Sally is, in this case, Sally is, Tom, I think Tom is Sally's boss. She's the secretary, but they're also having a love affair. And so Sally is, oh no, that's not this one. Yeah, that's another episode. Yeah, this isn't the right one. So, so one of the interesting things you can do, though, is you can see, so you can specify different distributions. So Tom sees himself as an executive. When he's interacting with Sally, oh, this is the one, yeah. I think I changed the first one. Anyways, Tom sees himself as a little bit of an executive, but a lover, but he sees Sally as a lover and a little bit of a slut and a secretary, right? So he's got a different view of Sally than she has of him. You can also do things like specify Tom's view of Dave. Dave is Sally's husband, and Tom doesn't know Dave. And so you just leave this blank, and it means that Tom will have no idea who Dave is. So it'll start off with a completely distribution which is spread over all the identities in the dictionary.
So you've got those descriptions on the back page under examples of your little handout, just to at least kind of explain how in his code it looks.
So I think rather than, maybe what I'll do is I'll start this again and maybe I'll go through this one rather than the interactive one.
Okay. Go through the love affair.
Well, I mean, I think it's, for some reason it's got a slight modification to it there, but I think I went in, I think it was supposed to be test sim 2B, which is not included, but let's just try this. This one's just a little bit more interesting because it'll have some multimodal distributions. And it seems to have.
It just takes a second. They're like fighting with each other.
I have a question while we're waiting.
Yeah.
So I saw that there was male and female emotion and impression equations specified there, but I didn't see male and female dictionaries being specified.
Yeah.
So does it pull in the dictionary and then you choose the viewpoint, or is that?
No, so okay, so there I haven't implemented we haven't implemented the gender. You would have to define two different dictionaries, one for males and one for females. Like the Indiana dictionaries have, each row of the dictionary has a label, EPNA for male, EPNA for female. And this software just reads the first three and forgets the rest. And so you just have to make another dictionary for females and use that one, right? So in fact, everybody in these simulations are males, even though they have female names. So, but you could, actually I think I'm using the dynamics equations for females, but you can specify it all in that text file, right?
The Georgia dictionary that we use is probably combined.
Yeah, I think it's combined, yeah.
We didn't find evidence that would suggest that you split.
Right. But the thing is that using those text files, you can specify, which will eventually be in these tabs, you can specify any dictionary you want. So you go and construct your own dictionary and put it in there, and then you can use it, right? So, okay, so this is these are these distributions now. So these ones are coming from this Georgia data, right? And they include the full covariances. And so you can see what's happening is that the covariances in this data is huge, right? And so this is the spread of points. This is a set of samples drawn from these two identities. This is Sally and Tom, so this is like secretary and boss again. But you can see that they're really spread out, okay? But that is what the data, I mean, that's what this data looks like. So you can go to, so then up here you can select different ones. So you can say, let's see what Tom and Dave look like. Okay, and then this one's even more spread out. So this is the red dots are Tom's view of Tom, and the green dots are Tom's view of Dave. Is that right?
Yes.
And remember, Tom doesn't know who Dave is, so you can see the points are just completely spread out all over the place, right? So the variance is much, much bigger. Okay, so the scale, I mean, you talked about 4.3 yesterday. In BayesACT, that means nothing. The 4.3 is not a limit. And you can have EP and A go off to whatever it wants. There's no constraint on it to stay within minus 4.3 to 4.3. That being said, I don't know why, because these should all be within that range. So it may be the case that this scale is not 4.3 to 4.3. There's something going on with the display there.
That's more than
should be plotting
Is
the.
it just part of the distribution, or is it labeled identity?
It's part of the
Oh, I'm
distribution.
sorry. You're
The
right.
labeled
You're right.
identities in the dictionary.
No, so these points are actually random draws from a multinomial normal distribution that has a covariance matrix that is the same as the one from the data. Okay? So that means I am taking the Georgia data, computing the covariance of the data, and then drawing a random sample from that. So that normal distribution then, just normal distributions go to infinity, so there's some probability that I draw a sample way out in the middle of nowhere,
So
right?
these don't have labels associated with them, but if you check the dictionary box, it will overlay the dictionary values, so you can see what labeled EPA values are nearby, like where things pile up, if you are interested in that.
But if, yeah, I totally get that mathematically, numerically, that BayesACT has no limits, you know.
Right. Right.
It doesn't go from +4 to -4. But what does that mean intuitively, theoretically, about labeled universe, in the sense that our dictionaries only go out that way? So once something, yeah, so would you say something like, that person is so villainous that I can't even think of them
Yeah.
as being a villain, because they're more negative and more powerful and whatever?
Yeah, so my feeling. Yeah, my feeling is that there's some there's some kind of squashing function at work, and it is the fact that when you do these semantic differentials, the endpoints of the scale are infinity, right? And so you say infinitely powerful does not give you a plus infinity in p. It gives you a plus 4.3, right? And so there's some kind of squashing function at work there. And somebody should figure out what that function is and how it's getting into this model. But you could put that squashing function into BayesACT, and then then those values would never move beyond 4.3, right? And the whole mechanism would still work. It's just that the normal distribution wouldn't have tails that go to infinity. They'd be squashed to 0 after 4.3, right? So you'd be working in a bit of a non-Euclidean space, which is fine, right? You could do that in BayesACT. So a squashed Euclidean space. Something about INTERACT is INTERACT is doing this anyways, and I haven't quite sorted out where that is happening, but it's in there somewhere. So for now, we're just kind of ignoring that and moving on. So, but somebody should look into it. Yeah. Okay, so then what you can see is the current identities in this case so they've already looks like been, oh yeah, so this remember is Tom and Dave. So I'm showing you Tom, on the left side here is Tom's view of Dave. Oh, sorry, Dave's view of Tom. No, because this one is Tom. See, this is where this isn't working. So let me see if I can simulate just from Tom's perspective. Yeah, there's something wrong here, because I think in the text file, this was Tom's view of. It doesn't go on that far, but anyways, or Dave's view of Tom. Here we go. Okay, so Dave views himself as a husband, a hero, and a father. So husband and hero are about the same, and a little bit of father sprinkled in there. And he doesn't know who Tom is, and so he's got this distribution over all the identities, right? So the denotative distribution is over every single identity in the dictionary. And so there's one that's a little bit higher, but essentially these are just all the identities in the dictionary. So he has no idea who Tom is. Okay, so then you can look up, well, what would he do in this situation? So you can say next behavior, and next behavior will show for Dave what he should do, and these are based on the fact that he has no idea who Tom is, right? So let's see, he's going to seek advice from Tom, and we'll say Tom will not act. Okay, so this is a situation where you can have both actors acting at once. So I could have Tom simultaneously doing something to Dave. So I'll get him to do something kind of nasty. Well, maybe he could kiss Dave. How's that? That's good. Oh, I know. He can just go right ahead and have sex with Dave. Okay. Okay, so now we're going to run. So you click on the run button, and this should do one update of the model.
After a brief delay, it makes the live stream stay.
Okay, so you see that it's collapsed down a lot, but there's still these. Now we're down to some very specific hypotheses about what's going on. So I'm not going to be able to explain this very well because I haven't actually run through this simulation myself.
We didn't wind up back on the current simulation tab for what it's worth, automatically. We're still in the next simulation activity.
Yeah, why does it collapse to these discrete clusters that are far away from each other? Why would it be?
Green is with green and red is with red.
But that's a lot of,
Why are the green ones so far from the
yeah,
other green ones?
that's a lot of space between green clusters.
Well, he's starting out with this massive distribution, right? And then there are certain parts of this that make sense, or I guess there are certain of these identities, maybe they are far apart, that make sense with those behaviors. So maybe.
Flip the dictionary button. Let's see what's nearby those chunks. He's got a multimodal distribution. They both have two hypotheses, basically, two main hypotheses about what's happening now.
But they both observe the same thing.
No,
Which is, Dave, I can't remember who did what, but Dave seeking advice and Tom having sex with it. And so given that they both, is it because they're two events that have happened simultaneously?
Well, that's part of it, I think, but I don't know. I mean, we'd have to look in to see what's happening in the simulation. But those, whatever the case is, those blobs that are there are the ones that are consistent with the actions that just happened, right? So let's look at what's happening over here. So what you're supposed to do is you're supposed to now go over and look at the current identities and see how they've changed. So now Dave is still seeing himself as just hero and husband. So he's lost the identity of father through this. So I guess he wouldn't imagine that he's not going to be a father in a situation where Tom's having sex with him, maybe. And he sees Tom as a psychologist. So you can see the number of identities that he's got for Tom now have shrunk drastically. So Tom might be a psychologist with probability 0.5 or a sheriff, and then a couple of other ones are still left. Okay, so that's his denotative interpretation of the.
It's spaced down to a few discrete hypotheses usually, and then you settle on one. So this is what we found over like a few simulations, at least with the previous version of BayesACT, is that I just.
But instead of it squishing it into some point, it seems to be mushing it into various.
Yeah, but remember how he started. They started with having no clue, right?
Yeah, and we definitely get why it shrinks, but why is it coalescing on multiple points?
They're different.
Well, they're also.
There's multiple.
Why isn't it collapsing rather than going to bimodal or multimodal?
Keep in mind that he's using. We were planning on starting this with the regular mean data, but you use the covariance data.
Yeah.
So this means that we're working with all the variants that actually exist in the real dictionary. So if people disagree about meanings, then that's coming into this.
So this is exactly
The same action can mean multiple things, it's ambiguity and uncertainty.
So if you and I are if we're seeing the situation as the same thing, but you think a colleague is hero-like, and I think a colleague is kind of dull compared to what I'm used to. And then you ask a question, and I seek advice from you, and you think of asking a question as being a super intellectually lively thing, and I see it as being, I get
Except
it now.
take that example and extract it from individuals' points of view to culture.
Yeah.
and say that what we're doing when we're forming a belief distribution is we're projecting a hypothesis about what we think beliefs are in the world, right? We're modeling basically, if we assume that this dictionary is representing the whole full set of range of cultural beliefs that exist in the world, we're modeling a person who, as they're trying to say, like, I'm trying to guess how you're going to react based on the fact that, like, let's assume this is a situation where I don't know you that well,
Yeah.
then I know some people feel like this about collaborating, and some people feel like that about collaborating. And so I'm actively now, with the covariance matrix, integrating those things into the hypotheses that I'm forming.
So basically, if we
about who you
use a
think I am.
dictionary that didn't have covariances in it, then it would be acting the way we thought it would act, which is.
Yeah, I would think so.
Yeah.
More so, yeah.
I was making an assumption too that Dave or whoever is aware would be aware that other people might think that that's what's something.
Right, and this is where we get into the meta, like when I was saying, like, how far down the rabbit hole of the decision tree do you want to go? Because I think most people in most situations are not thinking that hard.
But here, Kim, there is no decision tree here. That there's no planning going on here.
Okay.
This is just raw BayesACT.
Yeah.
So we haven't put that in either.
Yeah,
So,
yeah.
but I can show you that as well. I mean, all of this is much on the command line. You can see everything going on, but you can't see this nice visualization. So, okay, so I'm just going to do. I think we're sort of running close to time here, right? 1:30 is the end of this session.
Yes.
Okay, so I'll just do one more and see what happens. So I'm going to make Dave fall in love with Tom, and Tom will propose marriage to Dave. I mean, they really went fast, but.
But we don't have much time left.
We don't have much time, so it's high time that they. Okay, so you can see that they're now down. These ones, the red ones, so this is Dave's view of himself, are collapsing even more. And now he's only got basically a bimodal distribution over Tom's identities. And so then what you need to do is go into his current identities and see. Okay, so now he thinks of Tom as a patient or a chiropractor. What that means.
We don't have institutional filters in this data yet. So, does the Georgia dictionary have institutional filters? You don't have,
I have some for the.
Jesse, do you have those filters?
No, they're not implemented yet, but we could do that.
Okay.
I collected some for the chemical pertinent.
Yeah. Okay, good. Because that's a clear next step for us, I think. I mean, obviously we have work to do in how institutions could get implemented in a less like heavy-handed way than this, but until we do, that could be a really useful thing to have in here as well. That's great. Because if we can add that to the covariance matrix, then that would be awesome. Anyways, I mean, we're pretty much out of time. I sort of knew we weren't going to be able to get too far into this, but at least now you guys have a passing familiarity with what the interface looks like, how you can navigate the files. I'd really appreciate it if you would play around with it, try to break it, tell me what's wrong.
So I just made Tom do something badly, persecute Dave. And you can see identities like freak.
Borrow somebody's Mac.
The method
Borrow
is.
my computer.
Quick question.
Yeah, then it would be make it a little bit more.
Could you specify that you wanted to work without the variance to sort of get a sense, does it work like, in the past you can make it work like Interact, essentially.
Yeah,
But
the Mimic Interact button sets the parameters to do the closest approximation of Interact that BayesACT is capable of doing, and they're super collapsed distributions. And you can use the regular mean dictionaries instead of the covariance dictionaries.
okay, so that would be kind of a first.
That's what we
if
were
I look
planning
at
on
a-
doing first
yeah, I would
today,
like,
but everything takes
yeah,
longer.
and then you can
than
add
it's
what
going
is
to.
variance. It'll be
It's
really
just a rule.
interesting to go from here's means to what is variance to.
Yeah, we're going to show you guys the interactive version of that, then the BayesACT version of that, then this. But we just cut right to the chase, and now they're married, and
Actually, I made them have a breakdown already, so it's all Yeah, so anyways, it's early days yet, but the simulations are all running. If anyone wants to play around with the actual code and try to run the simulations on the command line,
Is that on your site?
then I haven't made it available yet, and you have to have a C compiler to be able to compile the code, which we could maybe get running.
Yeah. But then the command line prompts are really straightforward. It's like Tom : Dave.
Yeah.
You know, it's really straightforward. Like if you saw a file of how the code had been done for these, you could manipulate things very easily.
Yeah, we can maybe produce a version. I don't know, Doug, whether we can make that
So
command line.
folks that have been running simulations for a long time, you might prefer the flexibility of that interface, but for like walking students through how the model works, you know, I have the hardest time explaining this stuff in class, and it, like being able to have them generate things and see what happens, and you know, so we're trying to come up with kind of a multi-tiered approach so that there's points of entry for computer scientists, for social scientists that are at their level, and encourage more people to get engaged with the new models. So
George, do you have a question?
You have a stylish way to close the program? Have them both not active.
yeah, that will
Okay.
break the simulator. Yeah, it won't run if nobody does anything. So somebody's got to do something.
The blue numbers probability is always at one.
I believe so.
There's no way that it should always run.
They certainly should.
Yeah, I killed it.
Simulation.
Thanks, Josh.